So, definition of the number e. We met already one definition, if you remember. That was indirect definition, not explicit definition of the number e, and it was like this. So let me call it indirect definition. So this will be definition number 1, and it's indirect definition. In other words, we are not going to say e is the number equals something else, but we're going to say that e is a number that makes the following a true statement. And as I said, we've seen this before. This is the limit as h approaches 0 of something to the, well, that something will be e to the h minus 1 over h. If you have a number right here, imagine that there is a box here, and you try all kind of numbers, right? And you let eh goes to 0. If this number is such that the limit of this number raised to the power of h minus 1 and divided by h equals 1, that number is e. Okay? And we've seen this before, and you see that this is not a direct definition, as it doesn't state that e equals something else. We don't have explicit definition in this case. Okay? So we're going to look now at the second definition. In the second definition, we know from the previous material that the derivative of the natural log of x is 1 over x. Okay, so given that the f of x equals the natural log of x, and f prime of x is 1 of x, right? And another thing that we know and this is not from calculus, that f of 1, which is the natural log of 1, I'm sorry, we looked at f prime of 1. F prime of 1 will be simply 1 over 1, so it equals 1. Okay? So we use this information. So this is given. And now we're going to say by the limit definition of the derivative, we have the following. Okay? We're going to say that f prime of x, by the limit definition, it's the limit as h approaches 0. If you don't remember, it will be f of x plus h minus f of x divided by h. Okay? And in particular, because f of x is the natural log of x, as we stated here, so it will be the limit as h approaches 0, and here we'll have the natural log, instead of divide by h, we multiply by 1 over h, and then we say the natural log of x plus h minus the natural log of x, like so. Okay? So this is what we are working on, and now, since I know already that f prime of 1 is 1, so what we're going to do, we let x equals 1, right? And and f prime of 1, as we stated here, equals 1. So on the left side, we'll have f prime of 1, which is 1, and on the right side, we have the limit, except in this case, we're going to substitute x with the number 1. So on the right side, we have the limit as h approaches 0, 1 over h, but instead of natural log of x plus h, we'll have the natural log of 1 plus h, like so. And then minus the natural log of 1, but recall, the natural log of 1 is 0, right? So what survives after that is the following, is the limit when h approaches 0 of 1 over h times the natural log of 1 plus h. Okay? Let's put the bracket here. And now let's go to Michael's issue on the board before class started, right? But in reverse. Remember what we said. If you have a number that multiplies the natural log of an argument, then it will be the natural log of the argument raised to that power. So the multiplier becomes an exponent. And that's exactly what we're going to do here. We're going to write this as the limit as h approaches 0, but it will be now the natural log of 1 plus h raised to the power of 1 over h, like so. Okay? And of course, everything is inside the limit. Now, we have one more clever thing to do here, and I'll take you to the next page. The clever thing that we want to do at this point is remember the limit of a composition. If you have a limit of, let's say, f composition g, we can write it as f, the limit of g, right? In particular, because we have the limit of the natural log, I can say, and inside you have g, which is 1 plus h to the power of 1 over h, I can say that 1 equals, and I'll take the natural log outside, and I'll put the limit inside. And that's a property of the limit, one of the properties that we learned at the beginning of the semester. So it will be the natural log of the limit. Again, what I'm doing here, I'm saying the limit of a natural log of an argument is the natural log of the limit of that argument. Okay? The inside function is 1 plus h to the 1h. So we have the limit of 1 plus h to the power of 1 over h, like so. Okay? Now, we need to think about what is it that we are saying here. We have 1 equal the natural log of something else. Okay, recall that the property of the logarithm, okay, recall the following. If 1 equals the natural log of, let's say, something, let's say big A here, what does this tell you? It's the same statement as e to the power of 1 equals a, right? Or a equals e. Because remember, what's the natural log does? The natural log returns the exponent of the base, and the base of the natural log is e, and the exponent is 1. So e to the power of 1 is a. Now we have 1 here, right? So the limit equals to, or in this case, e to the power of 1, or e equals the limit as h approaches 0 of 1 plus h to the power of 1 over h. And this gives you definition number 2. E defined as the limit. Instead of h, let's use a generic variable x. Okay, we let x equals h in this case, and we have the limit as x approaches 0 of 1 plus x raised to the power of 1 over x. So here's another definition of the number, the natural number e. This will be definition number 2. Okay. Now this is, although it's a known definition, we can modify just a little bit and get a better known definition of the number e. The modification is very simple. Okay. I'll use, let's use another variable z. Okay. So here's the modification. We're going to let z equals 1 over x, and therefore x by itself will be 1 over z. And we'll substitute. So the other thing is, notice as x approaches 0, then z being 1 over x approaches infinity. Okay? So now we have the following definition. We'll do the adjustment. Instead of the limit, as x approaches 0, we let z approaches infinity. And instead of 1 plus x, we'll have 1 plus 1 over z. And instead of 1 over x here, we'll have z to the power of z. And this is a little bit more known definition of the number e. The difference between definition 2 and definition 3 is, in definition 2, we let our variable of the limit to go to 0. In definition 3, we let the variable of the limit to go to infinity. That's all. Okay? So if you like to use large numbers, you can calculate, let z equals 1 billion, and you get a number very, very close to e. Matter of fact, if you let z goes to 1,000, that will be a sufficiently close approximation to the number e. On the other hand, when you look at definition 2, you might as well let x go to 0.001 to get a fairly close approximation of the number e. And we can put this in Excel and come close and see how it works. Matter of fact, that's what I'm going to do now to give you a flavor of this thing.